Video here. Video here. Okay, cool. I just make sure confirming the image works. Okay, gentlemen. So welcome. We are in the home stretch, right? So this is it. Let's do a brief synopsis or review of the remaining schedule, right? So the last time that I'm going to take attendance is this upcoming Wednesday. So I just took attendance now. I'm gonna take attendance again on Wednesday. That's going to be the last day that I take attendance. That's also the last day of class. So this upcoming Thursday and Friday is the reading period, right? So we're going to meet on Wednesday. Then that's the last time I'll take attendance. Your final exam should become available this upcoming Sunday at 11:11 a.m., right? So just like the other exams, unlimited attempts, but it's going to be due the following Friday at 11:59 p.m., right? So you have from Sunday to Friday to maximize the score. You get unlimited attempts, but there's no late penalty because you cannot submit it late. Once, remember, that Friday, December, what is that, the 9th? Friday, yeah, December 9th at 11:59 p.m. That's the hard deadline for all assignments on Pearson. So what that means is that all of our homework, quizzes, and exams, everything is going to lock out at that time. So the recommendation is that if you're going back to improve your overall score, you want to prioritize your old exams. That's where you're going to get the most bang for your buck. The thing that you want to prioritize last is the homework, because that's going to be a lot of work for minimal points. The exams count for nearly 80% of your overall grade. Actually, for you all, it is 80% of your overall grade. And then, so the idea is that when you submit your final exam, you should be done, right? You shouldn't have anything that you're trying to work on past the final, okay? If you need help, you just need to speak up. You got to ask for it. You know, we can work on some of this stuff together. We can work on it during class. That's actually the intent of class time. I would encourage you, if you do need help, either collaborate with your classmates or link up with the tutors and get the stuff submitted. It's a lot of work, but it's doable. It's totally doable. I don't know anybody else that kind of does it this way. I don't really know what my colleagues do, but this works for me. And then one other thing is that, so during the week of finals, that Monday and that Wednesday, my goal is to basically be online and be available basically during like our regular class times. So I'll probably be like sitting on the Zoom call. I might be on here like from like 9 to 5. I might take a break around 10 o'clock, but I'll be back. I'm usually back by 1. That's when my next class starts. But otherwise, I might just sit on Zoom. I might like stream a game or something. But if you need to find me, if you have any like last minute questions or if you need help with the final or anything like that, again, I do plan on being on the Zoom next week on Monday and Wednesday from 9 to 5. Okay. All right. So that is the long and short of all of that. And so basically, when it comes to calculating the final grades, I'm going to wait until that Saturday after midnight, right? So because everything is due Friday night. So then Saturday morning sometime, I'll pull all the grades and start calculating final grades based on what's on Pearson, okay? All right, let me see, do we have any stragglers? Okay, we're looking good. All right, so what we're gonna do today, we're gonna go ahead, sorry. Let me see. So this is College Algebra 2 together as we can, right? So I have exam 2 pulled up here. I mean, this is fun. So here we're asked to find and simplify the difference quotient of this form, right? We got f of x. So difference quotient, so it tells us that a is 3, right? So we could find f of 3. We could just basically plug in a. When you plug in 3, 45 plus 3 is what, 48? So we're going to have f of x. I guess I should write it out. I'm trying to, I mean, we can do it here. So, you know, if you let a be 3, right? And then we said what, 48? So we're just going to say f of x minus 48. So I'm going to do this 5x squared plus x. Okay, we said what? F of a was 48, so we're going to say minus 48 divided by x minus 3, okay? So can we factor that numerator? What's that? 200, 240? I think so. Okay, maybe I should write this one out because we need to factor the numerator and see, can we simplify this guy? All right. So let me get a screenshot. Oh, wait a minute. Yeah, we're good. Okay, let me hit done. Copy and delete. Okay, let's paste here. Hello. Okay. Oh. All right. So again, on top, we had 5x squared plus x. Now, when a is 3, that's going to be 9 times 5 is 45, plus 3 is 48. So we're going to say plus 48. Actually, it's minus f of a, so that's going to be minus 48. Okay. And then on bottom, we're going to have x minus 3. Okay. So then we want to ask ourselves, it looks like that top possibly could be factored. 200, 240. So we're looking for two numbers that multiply to give us a negative 240 and add to give us 1. Okay. So 240 is what? 10 times 24. So that's what? 8 times 3. 8 is 2 times 2 times 2. 10 is 2 times 5. Okay. 15 times 16. Oh, 15 and 16. Those are the two, right? 15 and 16. I was about to go through all the factors and stop at the line that adds up to 1, but then I realized the two numbers we're looking for are 16 and negative 15. Okay. So then I'm going to use the box method for factoring the numerator. Okay. In the upper left-hand corner, I'm going to put my 5x squared. Bottom right is my constant, which is the negative 48. And then on the other diagonal, I'm going to rewrite this plus x using the two numbers that we discovered. So it should be a plus 16 and minus 15. So we're going to have, one of them I'm going to put 16x, the other one I'm going to put negative 15x. Okay. So if we look at the two on top, what do the two on top have in common that we can factor? It looks like they both just have x. Okay. The two on the bottom is at least 3, 15, 3, 5, 3, and 18 is what, 6, 16? So it looks like we can factor out a negative 3 from the two on the bottom. And that's what they have in common. The two on the left, it looks like we can factor out a 5x. And on the right, is that 4, 40, no, 3, 30 plus 18. So 16. Looks like we could factor out a 16 from both of those. Okay. So the claim is that the numerator factors into 5x plus 16 times x minus 3. Okay. And I guess we could have used the x minus 3 as a launch pad, right? And let's just do a quick check. 5x times x is 5x squared. Negative 15 plus 16 is 1. 16 times a negative 3, 30 plus 18 is 48, negative 48, okay? So we can be confident in this factoring. And then these guys are going to cancel, and we're left with this guy here. Okay. 5x plus 16. Okay, let's go back and answer the question. Simplify. We finished with 5x. Wait a minute. I feel like something's off. 5x. 5x squared outer is minus 15 plus 16 and then minus 48. Okay, let me see. Okay, maybe it's that form. 10x plus 1. I think we would have to do something else, but that's fine. So we got 5x plus 16. Let's go with 5x plus 16. Five x plus 16. Okay. Let's go next. Oh man, it's a test. I'm not confident in that one. Okay, I think some of these we had to omit because they were like interactive figures. Man, my energy just was way down. By the time I get to like 3 o'clock, I'm like, I don't want to talk anymore. Let me see. Let me check on you guys here. Okay, I got you guys. Whew. Okay. Let me look at this one more time. I'm gonna let this be 2x. Something feels off. Give me just a moment. 30. Okay, I think it's fine. We're just gonna go with it. Okay, so the next one is this guy here. Let f of x be this, g of x be this, evaluate, okay, composition, right? So this symbol, we're asked to evaluate f circle g of 1, right? So, to the uninitiate, a lot of times students will look at this like, oh, f times g times 1. This is not multiplication. None of this that you see on the screen right now is multiplication. This is called composition of function. This means the second function inside the first function, right? So the second function being g, so basically we would do g of 1 first, and then whatever answer we get, we pass it through f, okay? So when x is 1, so 1 plugged into g, 2 is negative 2. When we plug negative 2 into f, negative 10, so negative 7. So it looks like this result is negative 7. Again, what I did here, I plugged 1 in G, I got an answer. Then I took that answer, I plugged it into F, and the final result that I got was this negative 7. Okay. So also, if we come across questions that are like interactive figures on the final, I'll just give people credit for it because I know that those don't necessarily work properly. So find the function f and g such that f composed g equals h, right? So the inside function being g, so we need to say f composed g needs to be h. So a good potential inside function here would be 8x plus 5 for g. Okay, so possibly d here. And then the outside function could be x to the power of 9. I'm going to go with d. Okay. All right. So this one is on transformations of functions. We got the square root of x plus 5. So then square root, the image of square root is the top half of a sideways parabola. Because that plus 5 is outside our basic function, that means our graph moves up by 5. Okay, so the only one that moved up by 5 is A. I'm just going to go with A there. I'm so used to getting instant feedback, so the test kind of like is unnerving. But let's keep going. Determine whether the function is even, odd, or neither. Okay. So let me write this one out just because I want to take some notes on this really quickly. Just refresh your memory on the definition of an even function versus an odd function. Right? What do we mean by a function being even versus a function being odd? Copy and delete. Can I just paste? You learn something new every day. Okay. Totally sleepy. I'm so ready for this holiday break. Like, I don't even be here. Like, this time of year, man, I am not here. Like, physically, I'm here. My mind is like halfway here. But the other half, the rest of me is like, okay, what am I gonna do? Am I gonna travel? Am I gonna make a cake? Am I gonna go hang out with people? Like, what am I gonna do? You know, that's what my mind be. Every year, like I can't do anything about it other than just get through it. Okay. Like, I don't know, like when you start to become a senior, you get this thing called senioritis where you just like, it's over. I don't care. I just want to be done with it. I keep getting senioritis like every year, every semester. Okay, let's see. Even, odd, or neither. So I just want to do a quick recap on the definition of even, odd, or neither. So I'll do this in purple. So when we say a function is even, come on, yeah. What we mean by a function being even, the definition of a function being even is when we evaluate f of negative x, we get back to the original. This is also the same as y-axis symmetry. Okay. But the main definition is the first line. The definition of a function being odd is when we evaluate f of negative x, we get a negative times the original. That's the definition of a function being odd. So when you evaluate f of negative x, if you get back to the original, then it's even. When you evaluate f of negative x, if you get negative times the original, that's odd, and that's the same as origin symmetry. Right? Origin symmetry is like every x comma y you have on the graph, there's also negative x comma negative y. These points are symmetric about the origin and equidistant from the origin. Like they're always the same distance from the origin and they mirror each other across the origin. Okay? So that's what the function being odd. Y-axis symmetry, origin symmetry. That's it, okay? So then if we want to test whether this function is even, odd, or neither, we need to evaluate f of negative x. Okay? So if we're going to evaluate f of negative x, the original is 1 over x to the power of 6. So we got this x to the power of 6, 1 over, and again, we're evaluating negative x, okay? So if we have a negative number to an even power, the final result is going to be positive, right? So this is going to be the same as 1 over x to the power of 6, which is the original. So we have f of negative x equals the original, so that means this function is even. So by that, because of this, then this function is even. Okay, hopefully this is clear. I don't really know unless you guys like speak up or whatever. What's the time? Okay, I feel like I got a second win. So, I mean, or you can use probability and just guess. And if it's 3 choices, you got a 33% chance of being correct, right? If you were to just guess. But again, chance favors the prepared mind. So the more prepared you are, the higher your chances of success. If you're not prepared, then, you know, it's the opposite. Describe the transformations that produce the graph of G and H from f, okay? So for part A, if the base function is x cubed, which is almost like an S, right? It starts in quadrant 3, passes through the origin, finishes in quadrant 1, okay? Let's see. So when we look at A, we see two transformations. We have a -4 on the inside of our base function and a -1 on the outside of our base function. So the recommendation is when we're doing multiple transformations in one equation is to work our way from the inside to the out, okay? So this says we should go to the right by 4 and down by 1. 4 units to the right and 1 unit down for part A. Okay, so I'm gonna go with B. And then for part B, okay, I see 1, 2, we have 3 transformations. A +2 on the inside, a minus multiplying by a -1 on the outside, and then subtracting 5 on the outside, okay? So working our way from the inside to the out, the +2 tells us to go to the left by 2, multiplying the outside by a negative flips it vertically, and then we go down by 5. So 2 units to the left, it has, okay, flip it vertically, so flip over the x-axis, okay, and then down 5. I think it's A. Yeah, let's go with A. We are halfway. Thank you. Stop. Okay, I'm just gonna go to the next. Okay, that's fine. So with all these removed questions, well, y'all should have some really high exam 2 scores. Okay, given basically we're asked to combine f and g together through addition, subtraction, multiplication, and division. Okay, and find the domains. Okay, so f, we see it there. So if we add these together, there are no like terms, so we just add them together. We're gonna have x to the power of 3 plus 5x squared plus or minus 5x plus 5, okay? So then for the domain, is basically going to be the intersection of f with g, all right? So then I think both of these, their domain are reals. So all reals intersection all reals is all reals. Okay. F minus g, okay? So again, no like terms, so you just list it out basically. Let's close this out, come on. Okay, so f minus g, so that's gonna be 5x squared. Oh, that's not a 5. 5x squared, okay, minus 5x plus 5 minus x cubed, okay? And same argument, both of their domains is all real, so then their intersection is gonna be all reals, which is A in this case. Okay, f times g, so we need to distribute g across f. If we distribute, we're gonna get, well, we add those exponents, 5x to the power of 5. 5x to the power of 5 minus 5x to the power of 4 plus 5x to the power of 3. Okay. And I'm gonna do the same argument, all reals. Then f divided by g. I'm just gonna leave it separate. So I'm gonna hit my division symbol. This division. So f is on top, so we got 5x squared. Nope, that's not a 5. 5x squared minus 5x plus 5 divided by x to the power of 3. Now, normally it would be all reals intersection all reals in this case, but remember we cannot divide by 0, so we gotta throw out 0. So we want everything except 0. So that's gonna be A. Let me check on you guys in Zoom. Get the student, come on. Okay. I think that was it for that one. Let's go on to the next one. Yeah, that's fine. Oh, was that it? No, that's not it. The functions f and g are given. Okay, remember, so again, this symbol means composition of functions. It means the second function inside the first function. So in this case, we're going to put g inside of f, which is basically what that means is we're going to write f like normal, but we're going to replace all the x's with g. Okay, so I'm going to take some notes here. So we're putting g inside of f. That means we're going to have square roots, but instead of x, we're going to have 4 minus 5x. And then minus 5. And then we need to simplify. 4 minus 5, so I'm going to go equals. Let's do a square root. 4 minus 5 is what? Negative 1. Let me think about this. Yeah, we can just lose the parentheses, right? So 4 minus 5 is negative 1. So then negative 5 minus 1. Negative 5x minus 1. Because we're not distributing, right? So we can just lose the parentheses and combine like terms. Okay. So then when we go to find a domain, there's a 3-step process that I do to find a domain of a composite. First, we find the domain of the inside function. Then we find the domain of the simplified function. I'm pretty sure he was here. And then we take the intersection of those results. So we find, again, for the domain of a composite, we find the domain of the inside function, we find the domain of the simplified function, and then we take the intersection of those results. So the domain of the inside function in this case is all reals because g is a diagonal line, okay? The simplified function, we cannot take the square root of a negative, so we need to look at that negative 5x minus 1 needs to be greater than or equal to 0. So then ultimately you get x has to be less than or equal to a negative 1/5. Okay. So then what I ended up doing here, again, the domain of the inside function was all reals. The domain of the simplified was basically all the numbers to the left of negative 1/5. So then all reals intersection, this half interval is the half interval. Okay. Yeah. Energy's low. Let's look at this one. Okay. So we have these several, this is a piecewise function. It's basically 2 graphs in one, but the first line in this case applies to when x is strictly less than 0. The second line applies when x is greater than or equal to 0. So find the domain. Okay, so normally these graphs would be all reals. Yeah, you can just go all reals because, you know, if the first one is restricted when x is less than 0 and its natural domain is all reals, then the intersection is just less than 0. You know, there's nothing unaccounted for. Yeah, I'm tempted to say all reals. Let me think about it. I feel like we should look at the graph because the second one is the right-hand side, the right half of a parabola, and the first one is half of a diagonal line with positive slope, right? Y-intercept is 3. Yeah, so yeah, it's fine. If we were to take these two graphs and switch them onto the x-axis, every x would be accounted for, right? So I'm going to go with all reals for that one. X-intercepts. So which values of these make y equal to 0? So for the first one, for line 1, if we set it to 0 and solve, when x is -1, which is in that set, all right? So I'm gonna go with -1 for one of them. I feel like I'm getting sleepy again. And then it looks like when x is 0 and the second one, y is 0. So -1 and 0 are the x-intercepts. That's where they should cross the x-axis. Y-intercepts, if we set x equal to 0, x can only be 0 in the second line. So then the y-intercept is also the origin, 0. So then the graph looks like a C, right? One of them is the right half of a parabola. The other one is a diagonal line. Yeah, I'm gonna go with C. Okay, so based on the graph, so for the range is the very bottom to the very top. If you were to take this image and squish it and flatten it onto the y-axis, notice that every y is accounted for, right? There are no holes or gaps or breaks when you do that. So we're gonna go all rails. Okay, gonna hit next. All right, guys. Okay, let's do this one. The graph of f of x equals x cubed, it says it shifted 6 units left, stretched vertically by a factor of 4, flipped over the y-axis, and shifted 3 units up. Okay, so let's start with parentheses x to the power of 3, okay? It says it shifted 6 units to the left, so that means we need to add 6 on the inside. So we're gonna say plus 6. Okay. Stretch vertically by a factor of 4, so that means we're multiplying the outside by 4. Reflected over the y, so that's flipping horizontally. So I'm just going to put a negative here. This one we might get wrong, but I'm just going to put the negative like that. Shifted 3 units up, so that means we're adding 3 on the outside. So we're going to say plus 3 here. Okay, I'm going to go with that, and I think I'm going to go ahead and submit the thing and check it. Okay, 7, that's fine. Let me submit. Let's see. I think everyone that we did. Let me check 20. Yeah, we didn't do 20. So it looks like everyone that we did, we got correct. Okay. Did you guys have any questions for me? Are there any questions? Checking you guys here. All right, so if there aren't any burning questions, we're gonna go ahead and end the session here. Let me go ahead and make a copy of anything that you saw me writing. I'm gonna make it available for you guys. Let me send it to Box. This is College Algebra 1. Boom. College Algebra 1. Lab is fine. Notes, updated daily, right there, okay? So when this bar finishes loading, you'll get a copy of anything that you saw me writing. And if there are any burning questions, we're gonna go ahead and end the session here. We'll meet on Wednesday. Wednesday is gonna be the last day that I take attendance. And yeah, from one beautiful mind to another, enjoy the rest of your day, guys. Take care. Peace.